Good afternoon, everyone. My name is Nazmia Kurniawati from Department of Electrical Engineering Polytechnic Negeri Jakarta. Today, I would like to present my research paper, Predicting Channel Gain Threshold for V2V Communications with Varying Doppler Shift Using Machine Learning. Vehicle-to-vehicle or V2V communications is an inseparable part of intelligent transportation systems. With this technology, man-made error accidents are expected to be reduced to 80%. The moving vehicle, which is the nature of V2V communications, causing Doppler shift to be happen. This shift reduces the receive power level. Adaptive modulation is one of the methods to increase V2V communications performance. Based on previous research, by adjusting channel gain threshold that control modulation scheme election can improve the poor performance caused by Doppler shift. Unfortunately, the threshold determination made in previous research is done by trial and error. In this research, channel gain threshold determination by using machine learning is proposed to solve performance degradation in V2V caused by Doppler shift. The research is started by modeling the system. V2V communication is based on IEEE 802.11p working in a 5.9 GHz with OFDM transceiver. The channel is based on mobile-to-mobile channel with double ring Rayleigh fading modeling. The Doppler shift value is calculated from the maximum speed limit determined by government regulation of the Republic of Indonesia. The green table shows the speed and the conversion result to Doppler shift. To make prediction, machine learning needs a dataset. To make dataset, simulation is done several times until the data is enough to be made a dataset. The simulation parameter is shown in the blue table. After dataset has been created, it is trained using random forest regression. Mean square error or MSE is used to calculate the error prediction. Based on previous research, it has low error compared to other machine learning algorithms. In random forest regression, the number of estimator is used to tune MSE value. The lower the MSE, the higher the prediction accuracy. The number of estimator which produce the lowest MSE is used to predict channel gain threshold. The graph shows MSE value for each Doppler shift. From the graph, it can be seen that the lowest MSE for Doppler shift 0.0017 is 0.5685 when the number of estimator is 1. Lowest MSE for Doppler shift 0.0028 is 0.7719 when the number of estimator is 838. The lowest MSE for Doppler shift 0.0035 is 0.3582 when the number of estimator is 8. Then, channel gain threshold is predicted using those estimator. There are two thresholds predicted for each Doppler shift. Lower threshold for limiting BPSK and QPSK occupation, while higher threshold to limit QPSK and 16 QIM occupation. For Doppler shift 0.0017, the lower channel gain threshold is 0.6 and higher is 0.9. For Doppler shift 0.0028, the lower threshold is 0.2 while the higher is 0.54. Finally, for Doppler shift 0.0035, threshold is 0.225 and 0.3575. The graph shows the effect of Doppler shift to the required SNR for each modulation. By using bit error rate value 0.001 as reference, it can be seen that the lowest required SNR is the communication affected by Doppler shift 0.0028 and the highest is 0.0017. The graph shows modulation occupation for each Doppler shift. The occupancies is in accordance with the channel gain threshold. For Doppler shift 0.0017, BPSK occupies the most percentage of the modulation scheme used. This causes the number of transmitted bits is the smallest among other scheme, while for Doppler shift 0.0035, 16 QAM takes more than 60% of the modulation scheme. This resulted in the highest number of transmitted bits. So it can be concluded that, based on random forest regression algorithm prediction result, the channel gain threshold for each Doppler shifts are varied. For Doppler shift 0.0017, the lower channel gain threshold is 0.6 and the higher channel gain threshold is 0.9. The lower channel gain threshold for 0.0028 is 0.2 and the higher threshold is 0.54. For Doppler shift 0.0035, the lower channel gain threshold is 0.225 while the higher threshold is 0.3575. Doppler shift 0.0017 required the highest SNR to keep bit error rate limit below 0.001, while 0.0028 Doppler shift required the least SNR. With the defined threshold, Doppler shift 0.0017 send the least number of bits, while Doppler shift 0.0035 send the most number of bits. Well, that's all from me. Thank you for your attention. Please reach me on this email for further discussion. Thank you and have a good day.